Okay, this topic is signed fraction addition, advanced. Here we've got a subtraction problem. And fractions, we all love fractions, right? Not. So we just need to work through this, and there's a few things that sometimes these ALEKS explanations leave some gaps that are a little confusing. So let's go through this explanation so that you can learn to read what ALEKS is explaining, and then we'll do a couple more examples. Okay, so the first thing it says is that we can rewrite 7 over negative 2 as negative 7 over 2. You know, that's just something to understand, that if we have 7 over negative 2, that's the same thing as negative 7 over 2, which is the same thing as sometimes you'll see it written as a negative out front of the fraction. Those are all the same thing. They're perfectly equal. It's no problem. You can write it any way that you want. They suggest writing it this way just so we don't overlook this little negative sign, which is a really common problem. Okay, so that's some details about this. Now next, it just says rewrite the fractions with the LCD of 10, the least common denominator of 10. So that's often a confusing step. I want to really clarify this step right in here. We're going to go over here and we're going to take a look at the negative 7 halves and the negative 2/5. We see that they don't have the same denominator, right? Those are different denominators, but they have to be the same. So we have to ask ourselves, what's the least common denominator? Or in other words, what's the smallest number that both of those numbers go into? Well, in small numbers like 2 and 5, it's pretty easy to come up with 10. But here's a technique for more challenging numbers, because you will get those. Always start with the bigger number and list that. Just start counting by that number. So start with the bigger number, 5, and then just start counting 10, 15, 20. You know, do a few, and then start checking each one. Obviously, 2 won't go into the first one, otherwise we wouldn't have to change anything. But we check each one. Does 2 go into 10? Yes, it does. So that gives us the new denominator. So what we have to do here is we have to rewrite each of these fractions with a new denominator of 10. And that's really not too hard if you just follow this technique. When you're doing this problem, write it down just like this. You don't have to use the different colors or these arrows necessarily, but understand that here's what we have to do. We have to ask ourselves, what do I have to do to 2 to make it a 10? Well, of course, we have to multiply by 5, don't we? Well, if we multiply the denominator by 5, we also have to multiply the numerator by 5. We always have to multiply both of those by exactly the same. Negative 7 times 5 makes a negative 35. And look, that's what they got right here. Let's do the same thing with the other one. What do we have to do to 5 to make it a 10? We have to multiply by 2. So that means we have to multiply by 2 up here. Negative 2 times 2 is a negative 4. So there are our two equivalent fractions. So that means they're the same with common denominators. That's where this negative 4 over 10 came. Okay, so now that we have common denominators, we can just write the numerators together above the same denominator. So we just combine the numerators. And in this case, we have to always keep track of our sign, combining. And we can use our previous rule. If we have negative 35 minus 4, bump, bump, change it to a plus problem. And now we look and say, oh, this is an easy plus problem with same signs. That means we add the numbers together and the answer has the same sign. So that means 35 and 4 is 39. The sign is negative. So there's our answer. Negative 39 over 10. Alright, lots of details here and lots of good explanation, good note taking. These notes will be really helpful in your notebook. Let's look at another example. So we've got 7 over negative 9 minus 2 over 5. Well, the first thing we need to do is figure out those common denominators. So I'm going to take and I'm going to rewrite this. I'm going to say, well, that's a negative 7 over 9. And I've got a negative 2 over 5. So I've got 5 and 9 I need to figure out what the common denominator is. Now, I'm going to use the technique for more challenging numbers. You may be able to figure this out pretty quick, but I'm going to start with the big number 9. And I'm just going to start counting by 9s. 9, 18, 27, 36, 45. Hey, bam, I noticed that that's divisible by 5. As I was counting along, I was checking each of these to see if it's divisible by 5. No, 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 yes. So that's our common denominator. So we can rewrite each of these with a common denominator of 45. And once again, ask ourselves, what do we have to do to 9? To make it 45, we have to multiply by 5. So that means we have to multiply by 5 up here. That makes negative 35. Down here in the next fraction, what do we have to do to 5 to make it 45? We multiply by 9. Negative 2 times 9, that makes a negative 18. Okay, so now we can rewrite this problem as a negative 35 over 45. And I'm going to write plus a negative 18 over 45. Because then that allows me to see more clearly that I already did my bump sort of right here. I have my negative 35 plus a negative 18 all over 45 because they have common denominator. And then we have a plus problem, same signs, add them together, and our final answer is negative 53 over 45. There you have it. These are pretty challenging, so here's one more example. Remember to take these notes and always follow the steps and be patient with yourself, and they'll go a lot easier. So we've got lots of different signs floating around here. So one common error students make is losing track of those signs. So be really careful with those. You know, one thing we could do right away is we could say, oh, well, that's a negative 8 over 7 minus a negative 5 over 3. We talked about this earlier in this video. If we do a bump right now, then all of a sudden we have fewer signs to keep track of, and that might help. You can do it now or later, but the bottom line is really pay close attention to those. Now our first step, well, second step in this case, common denominators. Negative 8 over 7, and I'm going to use this as a positive 5 over 3. We need to find common denominators between 3 and 7. What number will go into both? Well, again, you can go 7. Nope, that doesn't work. 14. Nope, 3 won't go into 14. 21. Bingo. So that's our common denominator. Multiply by 3. Multiply by 3. And we get negative 24 over 21. Here we multiply by 7. That gives a 35. So now we can rewrite our problem as negative 24 over 21 plus a 35 over 21. That can be combined, negative 24 plus 35 all over 21. And our final answer is 11 over 21.